Welcome, everybody, to today's webinar on optimizing concrete. My name is Raphael Scheps. I'm the CEO at Converge, and I'm joined today by Ben Grimsley, who is the high-performance concrete tech lead at Lithko, focusing specifically on sustainable concrete solutions. We're really excited, and I'm looking forward to chatting with Ben about how Lithko looks at concrete optimization problem space, and how Lithko thinks about concrete construction technology to drive efficiency and optimization across the concrete value chain. Before we get started today, let's go over a couple quick housekeeping items. First off, everybody logged in out there will be muted for the duration of today's event, so you can clearly hear our speakers. If you do have any trouble hearing us, use the chat function to reach out. One of the admins can help you troubleshoot. And submit your questions along the way. We will try to answer those, and as many of those as we can towards the end. Finally, we'll be sharing many insights today, but don't worry if you don't catch them all. Later this week, you'll receive an email with the event recording. Cool, so let's kick off. Ben, can you start by telling us a bit more about Lithko and your role there?
Sure. So Lithko is the second largest concrete contractor in the United States. As far as flat work goes, we do place more flat work than any other contractor out there. My specific role within the company, we have a high-performance concrete team consisting of myself and some other support individuals. My specific role is I focus on sustainable construction practices, as well as material science, whether it's mixed designs or actual individual sustainable materials.
Awesome. Thanks, Ben. And maybe we can kick off with Lithko's construction tech strategy. I mean, how does Lithko think about construction tech?
So we embrace as much technology as we possibly can. We typically look at it from the perspective of job first type of work, what necessarily fits into that particular type of work, and what can give us the best overall possibilities of success for the role, or allow us to use some non-traditional materials to actually complete work.
Awesome. And I guess the big question is why? Like, what competitive advantages does Lithko actually see in that digitization and use of technology? What's driving the use of tech?
In the past couple of years, there's been some drastic changes in construction, obviously towards the drive in construction with driving down the GWP or optimizing performances or operating lean. Different types of efficiencies have all pushed us in the direction. Well, how can we operate more lean when we don't have the typical type personnel and the typical materials that we had several years ago to be able to just throw money at the problem. When companies start looking at working lean or working in low GWP processes, you've got to find ways to give yourself assurances such that you can understand your operational timelines, you can understand your material timelines, your performance of the materials, and that the people in the field have the correct controls necessarily in place, since they don't have the numbers that they used to be able to watch these things and how they react, or how they continue to grow and react.
Awesome. Yeah, it's super interesting. So what I'm hearing is working lean and then lower GWP. And so is that coming from the customers, the end developers, and are there any particular segments that are really driving for that?
It's a mixture of different things. There are some governmental sectors pushing for it. The strongest sector pushing for it right now is probably the data center market, and individuals that have a focus on basically zero carbon construction. We are seeing interest from a lot of large owners and end users around the country that are asking for numbers and asking for regional benchmarks, and asking us for solutions on how do we meet those numbers, or how do we drive them even further down.
Yeah, so it sounds like there's a real need and demand now for lower GWP solutions, but then there's also an internal drive for working leaner. Is that right? Is that the best way to think about it?
Internal from us, from the perspective that anytime we can incorporate a recycled material or incorporate a material that's less expensive than cement, because cement truly is the most expensive material that we put into concrete. Any way we can drive those numbers down, then very much so. And then that goes back to efficiencies, eliminating waste and focusing on efficient production.
Awesome. Yeah, I mean, what I think is exciting here is ultimately you can bend cost and carbon at the same time, right? You can actually reduce your carbon emissions and ultimately use lower cost mixes, or increase your margin as a contractor, which benefits everybody in the value chain. Now, let's talk low carbon for a bit. I mean, if we look at novel materials, low carbon materials, what role do they play for Lithko? I mean, there's so many of them right now. I'd love to kind of dive into how you think about that.
There are a lot of them, and one of my primary functions is to stay ahead of those things and be able to develop the internal knowledge within the company that I can pass down to individuals that will continue to maintain that tribal knowledge within the company. Um, there's everything from recycled pozzolans that we've never seen before, such as ground glass or recycled recovered glass, or innovative aggregates that are being created from injection of CO2 gas, along with some other minerals that typically haven't been used for aggregates. So what we used to see as recycled concrete aggregate, basically returned aggregate. Now we're actually looking at incorporating greenhouse gases into materials to create aggregates and different types of cements that are coming out. And it's not cookie cutter concrete anymore. I had a leader when I worked in ready mix that looked at an individual with an admixture company at one point in time and said, there's always something changing. Where concrete used to be simple. It used to be cement, sand, water, and stone. That was it. We put it in the ground, we made it, it got hard, and we're done with it. Well, that's not the case anymore. Um, we can over design concrete and reduce the volume of concrete, but what are we actually changing? We're not impacting positively the sustainable embodied numbers of that project. So as we go forward, as we continue to get driven to truly to a zero carbon footprint concrete, we're going to continue to have to incorporate recycled materials. We're going to continue to have to incorporate collected gases and different innovative things that will continue to reduce our impact on the environment while still finding ways to use them as an enhancer to concrete so that we can drive the volume of concrete down, so that we can drive the GWP of the concrete down, and so that we can actually get to a more sustainable system.
Yeah, that's super interesting. And so am I right in saying you really got the optimization of existing materials, right? Using less cement in the mix, but we're really talking traditional binders or traditional raw materials, using them more effectively as maybe the first step. The second step, starting to look at replacements and substitutes that are maybe in the nearer term, some that are accepted today. Longer term, as we start to look at replacements that aren't yet accepted but could really change the game. And then you started referencing, I guess, mineralization into the material as well of greenhouse gases. I mean, how do you think about timescales for all these technologies?
We need them yesterday, if you want me to be honest. The rate at which we're seeing different and innovative cements such as 1Ts or the carboaluminates, or to your point, increasing cement efficiencies for the materials we currently have, or incorporating recycled materials, it's drinking from a fire hose at this point in time. So from a technology standpoint, we need to be utilizing concrete sensors and taking the human element as much out of the decision-making process as we can by utilizing technologies that allow us to understand what our environmentals are, understand how those materials will perform in those environmentals, and be able to give us a data point that says, okay, here's what you should physically be doing today so that you can get the strength that you need based on your operational schedule in whether it's 3, 7, or 14 or 28 days.
Yeah, awesome. And you touched on I guess, a point that we spend a lot of time talking about, right? Concrete sensing and more broadly using data to help enable the use of those solutions. I think what's really exciting is you've got all these novel recipes, optimization of existing recipes, future recipes coming up. Ultimately, tech brings assurance, right? And so I'd love for you to talk us through how you think about those enabling technologies in the context of all these low carbon novel materials.
So ready mix is obviously a big industry. There's a lot of individuals that are in it. There's a very small group of individuals that within that industry that understand how to truly optimize and run mix designs and truly optimize mix designs such that they're running them right at design plus safety factor. The vast majority of producers will do design plus safety factor plus another 2 or 3,000 psi just to make sure that they're meeting and exceeding, and they don't have to worry about the quality assurance and quality control of the materials. But again, I come back to, as we continue to drive down the GWP of mix designs, the biggest offender that we can throw into a concrete mix design is cement. So every time we throw it in it just to make sure that it meets strength, we're basically just continuing to cause the same problem that we were causing before and not physically reducing the GWP of the mixes. data points, historical break data, environmentals, concrete sensors, all of the different technologies that we can incorporate still come back to what does all that data mean? How do I collate all that data? How do I take all that data and come to a decision-making point? How can I take that data and understand what I need to do that day? Well, again, it comes back to software-based systems that can take all that data, analyze it, give us a good throughput of what the actual results have been and historically based on those environmentals and those actuals, and say, this is the route you should take, rather than having some poor individual in the field make that decision. And again, based on his physical tribal knowledge, not actual true data.
Yeah, that makes a lot of sense. And so Ben, I mean, your role spans sort of Lithko as an entire organization with all of its different regions and different types of mixes across the US. Um, I mean, if you could have all the data you wanted, I mean, what data are you really looking to capture? And help me sort of paint that picture of a future where data is ultimately driving every decision you make about the material. What are the key data sets you're looking for, and what would you want to take action on?
So regional materials, regional material performance that I can collate with environmentals. I was joking about it earlier, but I, I live in a beach community in South Carolina, and today I'm in Cincinnati, Ohio, where it's 20 degrees outside and snowing. So we cover a wide range of environmental, basically temperature, weather, all of those things impact how concrete performs. Regional materials, how they're produced and manufactured regionally. A cement in Philadelphia, Pennsylvania is not going to operate the same as a cement in Kansas City, Missouri. That they just have a lot of similar ingredients, but there may be some other filler materials that are slightly different. The chemistry may be slightly different. It may just react with water. The waters regionally may be slightly different, or the aggregates. All of those things have an impact on how the materials work. So being able to dial down to a region, dial down to a material, and dial down to ambient and environmental temperatures, and have all of those things to where I've got historical data associated with those, and I can turn around and make a decision point based on the mix to use that day. That's key. Because if I'm sitting in South Carolina telling somebody up in Cleveland, Ohio, or somewhere along those lines how they should be pouring concrete that day, what I'm seeing and what I'm experiencing in the region that I'm in isn't what they're seeing or experiencing. However, data is what it is. Good data is good data. If they can take the data and make a decision based on that point, run with it.
Yeah, for sure. And so what level of variability are you seeing actually across regions? I mean, if you have to ballpark it.
From a recycle perspective and from regional available pozzolans and from cements, it can be drastic. It can be as much as trying to reach a 4,000 psi concrete in a certain region, having to use 600 pounds of cement versus 520 pounds in a different region. And again, that may be the admixtures that they're utilizing. It may be the regional aggregates. It may be the cement performance. Maybe the amount of limestone replacement in the 1L cements. Maybe the difference between one region has a type 1, one region has a type 1L, and that's the key indicator between the two. It's too wide of a range to give a specific here. However, the materials and the available materials in the region are what typically drive those things, as well as the capability of a company to perform a consistent, reliable mix. That could dial down to the history and the cleanliness of the ready-mix trucks, just down to the blades or how it's batched or the control in the batch systems.
Yeah, that makes sense. So what I'm hearing is you'd love data on the constituents, the quality of the raw materials. So clearly working with the supply chain is super important in that respect. But then also performance data from the field. So we're talking strength gain to inform early striking, workability of the concrete when it arrives. I mean, all the key properties that are ultimately going to drive the decision around how you select mixes. And that kind of makes a lot of sense. I mean, I guess now let's move to that world where this huge data set exists. We've had sensors in the pores that are tracking the performance of every piece of concrete Lithko's ever poured. I guess that starts to become the dream world that we're working towards. In your view, how does mix optimization and let's use the buzzword AI start to play a role in all of that? And how do you see it impacting your operations?
So typically how low GWP projects are sourced now, we get a project with a desire for a regional bench line and a comparison of that project, a reduction of that project based on a certain percent. Some are asked for 15, some ask for 20, some ask for 25. I've seen a lot of 35% recently. What that means is interim CA in 2020 released a report based on regional benchmarks. It's highlighted in ACI 323, which Dr. Matt Adams just recently put out. Specifically, such that they collected a lot of mixed data from those regions and basically averaged out to what a 4,000 psi, a 5,000 psi, and a 6,000 psi's embodied GWP numbers are. That's great. It's a great start. We all needed a starting point as far as driving sustainable numbers down. Lithko approaches it from multiple different angles. We have some slab systems where we actually try and drive down the thickness of the slabs from a traditional 7-8 inch thick slab down to a 4 or 5 inch thick, or less if you can. That's a volumetric reduction in the GWP impact for particular materials. For the same note and for the same reasons, mix optimization for me, ready mix, and I mentioned this slightly earlier, but traditionally ready mix is going to be over designed. It's over designed to prevent the ready mix company from having to do rip out replace and the concrete contractor having to do rip out replace. But that over design leads to a lot of waste material being put into the mix design to get the minimum required strength of a design, but we're finding they're blowing it out of the water. Mix optimization for me and using a data hub would allow me to control the materials real time, such that if I'm given a project, I've given a desired reduction in GWP, I can do a value engineering as built, reducing the thickness of the slab and the thickness of other concrete members. But I can still add that one additional element of controlling the materials and the waste that are either being put into the mix designs, delivering a consistent required strength without wasting any material. And then at the end of the project, I can give a report back to the owners or the end users of the building, stating what their design, their original design, our value engineered, plus our additional reductions based on mix optimization and the actual materials used in the project, so that they can have a fixed actual number. But we have an additional method by which we can reduce the GWP impact of the concrete.
Yeah, so that's super interesting. So there's really a loop here, right, between the planning phase where you're really starting to use tools like Mix AI to help figure out what the perfect recipe would be for your environment, your use case, your geometry, and then sort of look to actually deliver the job, I guess, using sensors. So you're moving from sort of plan to track and tracking the actual performance of the concrete itself, all
Right.
the way to verify through Data Hub. Is that the right way to think about that sort of virtuous loop?
That is, and obviously the sensors give us one additional data point in which, you know, typically the two biggest issues in a construction project, especially a low GWP contract or project, is schedule versus GWP reductions. If I've got to be mobilized and I've got to know when I'm mobilizing certain trades, at what point can I actually get those trades on the floor? And sensors give us that additional data point stating, okay, well, based on the current growth rate, you guys can mobilize steel or you guys can mobilize the material that we need to store on this date in this area of the building, rather than us just having to sit around and wait for 28 or 56 or even worse, upwards of 90-day concrete cylinders.
Yeah, for sure. So I guess that's back to sort of the bending cost and carbon, because you can maintain your productivity levels or even
Right.
go faster and still use up ultimately a low GWP mix on that project in the right environments, at least.
Yes.
And actually, what we've certainly seen is if you take, say, GGBS-based mixes, there's so much higher temperature sensitivity than regular Portland cement mixes, which actually means in high temperature environments, they cure really quickly. In low temperature environments, obviously, they cure quite slowly, which has been a challenge for the industry. So yeah, I'm totally with you there, which is, the more data you have on the millions of mixes out there and the different recipes, the more you can actually start to drive better decision making. And so if you could predict any property of concrete using Mix AI, what would it be? What do you want to use AI for? What kind of predictions do you want to be able to make?
To predict any one particular, I would say probably current compressive strength, current flexural strength, and to an extent maybe maybe tensile, but the two important would be for me would be compressive and flexural, just to either make sure that the concrete's at a point where I can lift it, or the concrete's at a point where I can put material on it and continue to like forward to where the concrete's ready to take a stress, essentially.
Makes sense. Yeah, and I think that's interesting. So that's obviously the predictive AI models, and we've been spending quite a bit of time sort of working on building some of those, really getting to the accuracy levels where you can actually make useful predictions that mean you can take better decisions around the selection of mixes. How about generating entire new recipes? Do you think AI has the potential to actually generate recipes or adjust them?
I think there's always going to be an aspect of there's going to be an individual involved in driving or making those decisions down. But I think as AI continues to learn more about materials, learn about chemical composition, and learn about how those materials interact, then yes, we can truly drive towards some more theoretical stuff. I mean, there's some interesting work out there in high filler, low water cement ratio concretes that if you truly don't understand how your material works or what the minimum amount of water or other materials are, it's one of those things that is again data driven, that you've got to be able to have something that's able to give you a proper decision making point.
Yeah, for sure. And how do you think about sort of the like the trust in the AI model as a contractor, and sort of the confidence levels, the error bars on the outputs? I mean, is that something you discuss internally, and how does Lithko approach that?
Cautiously, I'm sure, like everyone else. I'm not sure why AI has gotten a bad name over the last couple of years. It's again, good data in, good data out, good decision making in, or good data in, good decision making out. Um, if you can give the system the right amount of intelligence, it will give you the results based on its historical understanding of the problem. On the same note, it can eventually, as it gains enough data, it can eventually give you, to your point, some intellectual insight into which you may be losing something, or you're not, or overlooking something, or overlooking a potential problem or a solution. Um, it's again a tool. It's a tool like everything else. There are a lot of tools out there that are dangerous, but when used correctly and used the way it's intended and given good data, this is the direction we've got to go as an industry.
Yeah, 100%. And I think you can sort of think of it in two ways. You can use the analogy of, say, the self-driving car, right? We're using AI in self-driving cars. They're now on the road. And clearly that's a mission critical, safety critical industry. The other side of this is, these AI models are producing outputs and predictions. You can still test them, right? You can still test
So,
them whether with sensors that are standardized under ASTM and ACI, or with cylinder crushes, to actually validate the output. And so you start to kind of get into the world of validated AI, as well.
that's why I feel there's always going to be an individual or someone involved, because theory is one thing, but application is another, practical application. And to your point, that is what the individual would be necessary for, is practical application of a potential solution.
Yeah, absolutely. And so you mentioned, the different properties: compressive strength, flexural strength. Um, Presumably, Ben, you want to be able to predict those in any environment from a weather perspective, hot weather, cold weather concreting, any geometry, I guess, as well, or thermal performances of the material.
Definitely mass. Yeah, I know that's where concrete sensors definitely got their biggest start and biggest boon in the industry is in mass concrete, but odd architectural shapes and odd, there's some different applications of it, but I wish it would take off more in the flat work or the vertical work. It's always going to be there in post tension. It's going to be there in some vertical work, but it's always going to be in post tension and mass. But again, as the technology becomes more astute and is capable of giving us more feedback and more information about what's going on inside the concrete, and as we all become a little bit more technically savvy, then it's going to continue to grow and continue to be utilized more.
Awesome. Yeah, and I guess I just sort of finishing that loop on AI. I have to bring us back to data centers, because data centers seem to be the whole craze right now with what's going on in the AI world. And obviously, the idea of using AI to optimize a data center that's going to house an AI, is sort of interesting. I mean, maybe we should just bring it back to that market segment,
Sure.
specifically, because I think we've talked about this in the past. You're seeing huge demands from that space. Yeah, how do you see the impact of these technologies in that sector?
End users, owners are very heavily driven, obviously, in the sustainability space. And this again is another, anytime we can control material, control waste, control inputs, lower GWP, these are all things that speak to, what the data center developers and the data center owners want. There are multiple applications for it. The vast majority of data center sites that I've worked on, we've had on-site ready mix or on-site, in precast or uh, multiple different operations going on at once. And so when you're operating a portable batch plant, you're shifting between precast concrete and pre-stressed concrete and shifting over to flatwork concrete. They're designed drastically different. They have different reactivity models. Obviously, precast pre-stress are typically trying to strip a bed somewhere in the 10 to 12 hour range versus, you're looking at more slower and evenly growing flat work or cast and place models. That's a lot of variability. That's a lot of variability for a very small team to have to deal with, especially from the perspective of shifting back and forth between the two. It's two very different mindsets with regards to batching and placing. So again, using computer systems or AI controls, or to that extent, an AI interactive batch system, to where we can take that variability out of the individual's hands and control that, be able to control how the environmental impacts are to the actual mix design constituents and switch back and forth between the two while taking out the human error element. That's big.
Awesome. And so we spent a bunch of time talking about AI and sensors as well, right? So ultimately using sensors to track the performance of the material, feeding that back into the AI model to make better choices, and predict the future really in terms of the actual performance of the material. You briefly touched on Data Hub, and I think it'd be interesting to dive into that. And as context, for everybody, this is the latest product Converge launched last year, really focusing on actually expanding the universe of concrete data that we're gathering. And maybe Ben, you can kind of speak to how you're thinking about tracking of embodied carbon, right? I mean, obviously there's all these targets being set, but how do we kind of collect the data, not necessarily the sensor data, but all the other records that you've got to keep track of, and centralize those.
The reporting coming up, and that's going to start being required on a lot of these projects. If we don't digitize this now, it's just going to become an exercise in futility. And I think the things that you and I talked about we were originally talking about Data Hub that are very interesting to me. Again, is the real-time understanding of material consumption, the real-time reporting, and in-job reporting of total materials consumed on a project, and how I can compare that to what my benchmarks were, or what my budget, my carbon budget was, or embodied carbon budget was for the project. And the more projects we do where reports like that are required, anytime you can take that level of work off my desk, where you got multiple Excels open, where I'm actually trying to calculate the exact volume of each individual mix designs, and then trying to compare that back to batch actuals. The batch actuals are not always going to be taken into consideration. However, in this particular case, utilizing something like Data Hub, I'd have the batch actuals, I'd have everything already entered, and I would know down to the pound the exact materials I used and the exact embodied carbon footprint of those mix designs in the project. And then all I have to worry about is my transportation costs or material costs, and go from there.
Yeah, I mean, it's always amazing to walk onto job sites today, and we had this just a couple of months ago, a major mega project, and we realized there were literally hundreds of binders with concrete records that were actually still paper-based, and ultimately that just means you can't parse that data, you can't draw conclusions from that data. So I sort of am totally aligned with you there. If you can actually start bringing all these data pools together, we're able to have such a big impact then on how an entire organization operates. And you could imagine that at the scale of all of Lithko's job sites, right? That would be invaluable in terms of being able to make better choices around the types of recipes that you can use, for
And can
sure.
give our customers a more realistic or actual truly embodied carbon number, which is that's their desire, is to understand what impact their building actually has.
For sure. And talking about the customer demands on GWP, I mean, you sort of referenced it earlier, 25%, 30%. I mean, how far can you go? with these current technologies, and how do we get to 0% embodied carbon, or I guess sort of full net zero?
That's a much deeper discussion. How far can I go? So I've
Let's maybe start with what are people asking for right now, and then yeah, how far can you go?
on average are asking for between a 20 to 25% reduction based on what the regional GWP numbers are. We're starting to see some more aggressive numbers. Like I said, there's several projects I'm working on right now that we're asking for 35% or greater just to see just how far I can take it. I actually just recently gave a presentation to someone that I was joking about because I work for an individual that likes to say that's great, but and I actually got that in the discussion where I was like, I was able to get you a 42 to 43% reduction in this region in this market, and I got that's great, but how far can you truly take it? And the truth of the matter is we were testing concrete. We were testing concrete, building mixed designs based on how we knew to build them and how we knew that would be on paper, and basically testing one new innovative material in the region that we were told by the vendor how it performed, but again, as a person, I wanted to do that for myself. I wanted to test it. I wanted to see how far I could push it. And I got some pretty aggressive reductions. However, if I had a theoretical model or an AI model that could show me, really truly how it would perform over a long period of time, then I can drive the number much lower. I think the 2024 NRMCA report is out. It's not necessarily been adopted as the benchmark for most regions yet. However, it is out and it's out there for people to look at. And the numbers that we've been able to reduce over the past 4 years between what the benchmarks were in 2020 and what they were in 2024 is great. But a 40% reduction off the 2024 numbers is much more drastic than a 40% reduction off the 2020 numbers. However, that's the direction we're going. I think from a design perspective, again, that we're still doing the traditional go out in the field, test it, like build a mixed design, test it, see if it actually works, see if it's placeable, see if it's finishable. But there's much more that can be done with a good modeling system than we're actually currently utilizing, and we should be utilizing across the industry.
Yeah, and so really what you're saying is there's actually sort of three stages, I guess. There's the design phase where you're really thinking about volumetric savings. Let's use less concrete in the first instance to make this building more efficient. Then you're going, hey, material selection. Let's build a great model around material selection to reduce its footprint. And then I guess there's the actual delivery, the as-built side of all this once you actually hit the job site and you've actually got to deliver. And so if we take these three stages and then we link this back to what we talked about right at the beginning, you've got optimization of existing materials. You've got novel SCMs, novel aggregates or replacements that are maybe in the near field. Then you've got sort of longer term materials. And then eventually you've also got kind of mineralization of CO2 into the concrete or various other types of technologies there. How do you piece that all together? Like how do you see the future? Let's talk the next 2 years, the next 5 years, the next 10 years. And what does that mean in terms of both digitization, but also greenhouse gas emissions?
In the next 2 years, I probably see a lot more incorporation of innovative cements. And obviously, as we go to 1T cements, where you're using more than like two or more pozzolans inside of a cement, the variability is going to be different across region to region. So the ability to understand what a 1FS ternary mix, so one fly ash slag ternary mix versus a one limestone slag mix, and how those individual materials perform. If we don't digitize or we don't actually have trackable performance across something where we can rotate around, we're going to end up in a situation where we've got 15 or 16 different types of cement variants based on the pozzolans used versus the carbolumets and the carbosilicates. And to the finisher, it's going to be, this is cement, it's supposed to act like cement. Well, it's not exactly the case. I would like to see over the next 2 to 5 years the ability for me to enter in a mill cert based on the fly ash replacement, the slag replacement inside the ternary, as well as what my regional pozzolans are, what my regional recycled pozzolans are, and be able to just play around with a system to where I can see how it will perform such that it's got a large database of historical data, but I can dial up or dial down a particular cement or pozzolan based on whether I need higher early, or whether or not I can let it play out for 56 days or more. Because if we don't have that, then we're going right back to the drawing board, where we now have a high level of variability between our materials or cementitious materials, and all we're doing is going out there in the field and spending, week after week of testing concrete in the field just to see what it does.
Awesome. Yeah. So I think what I'm hearing actually is you're seeing and you're envisioning both the chemistry and the digital side of things moving forward in lockstep. And actually, there's that future where the digital enabling technologies, the sensors, the software, the AI models ultimately help you start drive further and further adoption of novel materials. And you can't really do one without the other. And as we're starting to push through, right, from that 40% off of last year's baseline or 50% off of next year's baseline, we're going to keep putting pressure on the system, and then you need that tight control loop. Yeah, I mean that's a super exciting future that we're very excited about as well, in terms of sort of building that for the construction sector at large. Cool. I mean, Ben, thanks so much for all this. I think we'll now shift gears to Q&A. So we'll take a moment to see if we have any questions from the audience. And obviously, if we don't get through all of them, don't worry, we'll follow up individually after the webinar. Cool. So I can see we've got a bunch of questions here, Ben. And so the first one, how do you get people on board with the new technologies? Were there any strategies you used to ensure smooth adoption and minimize resistance?
That's a great question. People are naturally hesitant to adopt new technology. I think I kind of touched on this earlier, when I had a boss that was, this is concrete, this is what I was used to, this is what I came up with. I find, coming from a quality background, I've spent the vast majority of my career in quality assurance, quality control in different industries, from ready mix to construction to environmental admixtures. I found people are, especially in an operational role or an operational mindset, they want to see it, they want to touch it, they want to understand how it reacts, and if you can show them a value to it and you can show them that it performs as you advertise, then they'll adopt it. From a quality standpoint, what I always used to look at is, does it perform? Does it do what you're asking? Does it fix a problem that I have, or a potential problem that I have? And so when I discuss internally or externally the different technologies or different materials or different solutions or optimizations, that's the first thing I target. What value does it add? Does it perform as advertised? Does it eliminate or potentially eliminate, a potential problem? And again, that's how you'll get operational companies or operational roles to accept those particular technologies or materials.
Yeah, 100%. And Ben, how are you thinking about this from a stakeholder standpoint? Because I guess from my experience, one of the big challenges is you have probably 5 or more stakeholders, as in the ready mixer, the contractor, the general contractor, the developer, asset owner. How do you get all of those aligned in terms of using technology?
Well, I've actually had this discussion recently. They all have their own pain points, right? The developers and the owners want the sustainability numbers, or they want their building at cost, not at added cost. The GCs, they want their building on schedule and as designed and as specified. And the ready mix provider wants to be able to provide a material that provides little to no risk to them. And from a finisher's, from a concrete construction and contracting company, our preference is to be able to place it and not have to do any remedial work to it. Nobody wants to come back and do rip out, replace. Nobody wants to come back and fix errors. Everybody wants to be right first time. So each of those individual desires and pain points, you're overlapping. And so you have to be able to, again, show the same value or show the same correction of a problem or show the same reduction in risk to each of those individual stakeholders. And sometimes it's as simple as having or being able to test the technology, have an experience with the technology or the material, or have a history with it, such that, I do this all the time. I've solved a problem in the past, or I've identified a material that has solved a problem for me in the past, or a technology in the past. I'll bring it up. Sometimes it's in the moment. Sometimes it's preferably in the pre-construction phase, where we can say, this is a particular problem on this project because we're using very, very low GWP number or materials. This is what we need to utilize to make sure that we're reducing our risk from mobilizing our teams too early, or from placing loads on materials way before it's capable of taking the load and such.
Yeah, that makes a lot of sense. We've got a couple other questions. So one of them is, any thoughts on the use of biochar in the concrete mix?
Um, there are a lot of recycled waste materials out there, biochar being one of them. Again, it's and combusted organic material. I've got no problems using it. I've seen hemp as a replacement for fibers. I've seen numerous other things that have a biologic background. One of the things that first interested me about coming into the concrete industry is, as an oddball, I actually have a microbiology degree with a background in molecular biology for a graduate degree. And there are a number of companies doing work on concrete repair and using bacteria that were anaerobic bacteria when exposed to air would turn around and fill cracks inside of concrete. I'm looking for any innovative material that's recycled, bio-wastes. I know there's other materials out there such as graphite and graphene that, again, are biological in origin and have been converted into materials to use as materials in concrete. And again, test it, see what the value is, see what the problem it solves is, and if the problem is solved that it replaces traditional mined aggregates or replaces traditional cement, let's run with it.
Amazing. And then moving on actually to another question. So we've got bio-based concrete, and now we've got 3D printing. So any thoughts on using concrete sensors with concrete 3D printing? Concrete sensors plus 3D printing plus AI sounds really interesting. I agree. I'd be really excited for the person who asked this one. Let us know if you're 3D printing concrete. We can definitely get you a couple sensors. But yeah, Ben, what are your thoughts?
I know there's a couple of companies out there doing 3D printing in concrete. I think Sika did some testing for a while there for the military, doing basically quick design defensible positions, which I thought was a wonderful application of that particular process. Again, sensors in that particular case to understand when a material like that could take a load or take a ballistic impact would be a wonderful thing to know. I know there's a company out doing 3D printing housing and a number of different things. I come back to the actual thickness of the material. Not all 3D printed concrete technically is typically very thick. Usually it's a little thinner than traditional placements. However, there may be something there. There may be something, a need or a potential problem in the case that it would be worthwhile looking into.
Amazing. Well, I mean, I think we're really at a wrap now, and we've had 3D printing, bioconcretes, AI, and ultimately, I think there's a really exciting future ahead as we start to use all these technologies. A massive opportunity to optimize the material, and ultimately build some pretty incredible structures in the future, using both existing and novel materials. So thank you everybody for participating in today's webinar. Special thanks to Ben for sharing his insights. We hope you found the session valuable, and watch out for the recording. Feel free to share it with anybody who would find it interesting. If you do have moments to share feedback, we'd really appreciate completion of a very short survey. We've just shared the link. It should take 1 to 2 minutes to complete. And then lastly, if you're going to be at World of Concrete in Las Vegas next week, we'd love to chat with you in person. We're in the North Hall at booth N1177. Yeah, Ben, thank you very much. And it's been really exciting, and I'm looking forward to seeing how we keep driving impact in this sector.
Thank you all.
Have a great day, everybody.